Welcome, 6th graders, to your Chapter 11 review. This is on rivers and groundwater. Alright, so we started Section 1 talking about the active river, and we talked about this idea of uniformitarianism. We talked about how, like the Grand Canyon, for example, was formed by agents of a river. We said the Grand Canyon was formed by the Colorado River, and that was river erosion. That over a really long period of time, this river carved out the Grand Canyon. That on a small scale, even today, we can see canyons being formed by the rivers eroding and pulling away material from the sides of the river banks. And so eventually, over a long period of time, you could get something like the Grand Canyon. All right, we also discussed the water cycle. All right, and with the water cycle, we discussed how rain comes in the form of precipitation. So you have rain coming down, that rain collects and it forms little streams and rivulets, which then come down and they're going to join a larger body of water, so like an ocean or a lake. And then that water is eventually, some of it is going to what's called percolate down. It comes down into the ground, and you get something called groundwater, which will come up again in Section 3. We have groundwater. And that's percolation. When the water seeps down into the ground and is stored inside the ground in aquifers, this groundwater is stored in an aquifer, this area down here in between. There's rocks down here, but this is permeable rocks. The water can get through in between these rocks, and then it's stored in this underground reservoir, an aquifer. Water that doesn't percolate down, like I said, streams into, it collects in what's called runoff. Right, we have runoff from the mountain, it streams down the mountain, collects in a larger body of water, where then eventually it's going to evaporate. Right, you can't see evaporation, but I'm drawing it for dramatic effect. So you have evaporation, water coming back, the sun is, or energy from the sun is causing the water to become water vapor, and then that water vapor enters there, and eventually it collects in the form of condensation in a cloud. And then once the cloud is too heavy, that condensation is too much, it's going to rain, which is precipitation. You have this cycle of rain coming down and then evaporation coming back up. You have some water percolating down into groundwater storage. Now, I'll get into this, I suppose now, that in Section 3 we talked about using water wisely because groundwater isn't easily replenished. If there's not enough rain and we're taking out more water, so if you have like your underground water storage, you have an aquifer down here. So if we have an aquifer, this is our groundwater, and we say drill down, we make a little well, and we drill down, it's my little pretend well, and we're taking out water from the aquifer. This top of the aquifer is called the water table. It's that flat surface that's as high as the water reaches underground. But if we take out more water than is being replenished by water percolating down due to rain, we have percolation here. If we're taking out more, then we do what's called lowering the water table. Now we have to drill farther to get to water, because now, see, my well doesn't reach down into the water table anymore. I'm going to have to drill further in. And that can cause what's called settling. The ground up here is going to kind of shift and settle and kind of sink down. And you can't get back once it's sunk down, right? Once it's moved down and once our water table has moved, been lowered, it's not going to refill and just refill and be replenished. So being careful of how much water are we taking out of the aquifers, and are we taking out more than is being put in? That's part of being water-wise, especially in California, because we don't get a whole lot of precipitation and a whole lot of rain. So we want to be careful to not take out more than we put in. We also have to be careful about like factories dumping water. Right, if you have factory polluting the environment through like if there's chemicals in the air being put out like in the form of gases, those can get into the air and they collect in our clouds, and so now your clouds are full of pollution, and when the rain comes down, now our rain has pollution, and that can get down into the water table. Also, if a factory dumps some sort of material, say we got some sort of material coming out into like a little body of water, a little like pond or something, and they're dumping chemicals into this pond. Now when water leaves that pond, it can percolate down again, and you're contaminating your water table, and then it's no longer drinkable. And you're doing this permanent damage to the aquifer, which is one of our sources of water here in California. We drink from surface water, like lakes or rivers. And then we drink from aquifers or groundwater. Because remember, only 3% of the water in the world, H2O, only 3% is drinkable. Only 3% is fresh. And out of that 3%, remember, about 2% is frozen in like polar ice caps, so we can't actually drink it. So we have a very limited supply of water. So being conscious of our sources of water and really taking care of it is very important. So not contaminating our surface water sources by dumping things in our lakes and rivers, making sure that we're not contaminating the air and causing our rain to become acid rain, because then it comes down and collects in our drinking sources, both surface water and in aquifers. This picture shows how that pollution, right, comes up, gets condensed in the clouds along with the water vapor. It comes down, it's runoff, collects in streams, and eventually, I mean, you're having percolation into the aquifer, and like if you have a septic tank or like petroleum storage, all that landfills, all that waste and things, and like lawn fertilizer, oil from the roads, salt from the roads, all those things are percolating down and joining our water and contaminating our water source, our aquifers. And that's something that we need to be really conscious about. Like, what are we preventing or limiting the amount of pollution that's happening? So a few of the different acts that were made, we talked about last week. Remember the fire in Ohio. So the Cuyahoga River in Ohio caught fire in 1969 because there was so much pollution and oils in the water that the river itself caught on fire, and that led to the formation of the Clean Water Act of 1972. And the goal of the Clean Water Act, this was a federal act, so it was across the entire United States. The goal was to make all lakes and rivers in the United States safe for swimming and fishing. We have a bunch of other acts that we've since put in place. California has some, such as the Oil Pollution Act of 1990, so that all ships in U.S. waters have to have a double hull. So that means double hull is like an inside and an out, 2 layers basically around the outside of the ship, so that if it's an oil ship, if one of the holes leaks, that doesn't necessarily mean that the oil gets in the water, because oil is really hard. Oil and water, remember, don't mix, and so it's really hard to get rid of, and it's really flammable, and it kills animals. It makes it impossible for the fish to and like birds to swim through and to breathe in for fish, and so it's a horrible contamination thing, and it's really hard to clean up. And so by saying that you need to have double holes on your ship, like 2 layers to the outside of your ship instead of just one, you're making it so that if something were to happen, it's less likely that the oil is going to spill in the water. There have been like the Safe Drinking Act of 1975. There was a lot of programs aimed to protect the groundwater and surface water from pollution. So we've made a lot of laws and legislation in order to protect our water sources. Just because water, part of the water cycle, like those pollutants, go back after they've percolated down to our water table. They're now permanently part of the water table. And like if it's in the surface water, that surface water is going to come back up. It's going to condense in the clouds. So pollutants get carried up and they become part of the water cycle. And it's really hard to separate your water from the pollutants that have been dissolved in the water. Also, in regards to using water wisely, we talked about how California aquifers, all the gray areas are aquifers, that there's not enough water in our aquifers for all of California to drink. And we also talked about that they're not getting filled up fast enough, as fast as they're being drawn from. This picture here shows that average annual precipitation, so this purple area up here, gets up to 120 inches of rain a year. That's a lot of rain, but there's not a whole lot of population. There are not a lot of people up north in that little area, that rainforest area of California. The problem is, in California, we have a lot of population down here in this red area where we're getting only like 5 to 10 inches of rain a year. That's not enough rain to in Los Angeles area to provide water for all the people living there. So you have too much rain up here and not enough rain down in Southern California. So we mentioned this kind of water wars. How do we get the water to where it needs to be for the people to be able to sustainably live there? We also mentioned that this whole area here, the Central Valley, produces a lot of our produce for the United States. That's where a lot of farming is done, and there's just not enough rain there to sustain that farming. So irrigation, the way we water our plants, irrigation in California takes up to like 74% of our fresh water. We're watering plants in order to grow the crops. And so in the Central Valley, they're using a lot of water to irrigate plants, but they have to get that water from somewhere else because there's just not enough rain there. So one way that we've done that is the California Aqueduct. The California Aqueduct is this like it's like a tube that they built this big industrial way to carry water. Water is carried from Northern California into Southern California through this aqueduct. Okay, we go from north to south. And the water is carried through, and so we're transporting water from up here in Northern California down to our Central Valley where we're getting, where we're watering plants, and then into Southern California where we are giving water to people to drink. All right, so besides just water conservation, in this chapter we also talked about getting back to the idea of the Grand Canyon and how rivers erode, and then later they deposit their sediment. So they erode and take away sediment, and they later deposit it. So there's a couple different types of what are called river systems. And river systems are like a group of rivers. So you have like one main river. See, this here's my main river, and then I'm going to have a bunch of tributaries or smaller little streams and channels contributing or adding water to my main river system. So this is my larger river here, but all these smaller and smaller little channels or streams join together. These are tributaries. They contribute or add water to one main source. And a river system that's divided by different regions is called a watershed. And a watershed is just an area of land that's drained by a series of or a river system. For example, we have this highland. In the Rocky Mountains, we have what's called the Continental Divide. That's one edge of this river system, or watershed. And then on the other side, we have the Appalachian Mountains. So these two high points, in between them, all the water is draining in the same kind of direction. All these little rivers and tributaries, you can see they're contributing to these small little streams are adding to the Missouri River. The Ohio is joining the Mississippi. The Missouri is joining the Mississippi. The Tennessee is joining the Ohio and joining the Mississippi. And you have all these rivers coming together and joining the Mississippi. And so this is the Mississippi watershed. Whoops. The Mississippi River watershed. And that is the largest watershed in the United States. It's all the way from the Continental Divide to the Appalachian Mountains. There's a lot of smaller watersheds as well. But this is this huge river system. All these rivers joining together. And then they're draining into the Gulf of Mexico. So in regards to stream erosion, we have channels are the paths that streams follow. We talked about gradient, like how steep is the river, would be the gradient. If something has a steep grade, it means it's a really, it's going to be flowing really fast. It's a really steep river. So like I talked about with vehicles, with trucks. They'll sometimes have signs like this on the side of the road that say caution, like steep grade ahead, or 6% grade ahead, or gradient ahead, and they show like a truck on this really steep hill. And they'll sometimes say shift to low gear. And they're warning trucks that you have a lot of weight in your truck, you're going to be going fast down this hill, so be careful. That's kind of what this sign means, be careful, caution, it's steep ahead, so you're going to be going fast. So when you move a steeper grade, our rivers flow faster. If you're on level ground, the river, though it's moving, might not be moving very fast. Discharge is talking about how much water comes out of a stream in a given amount of time. So if you have a lot of rain, right, a lot of rain coming down, your discharge, how much water is coming out of your stream, it's going to be flowing faster. And more water is going to be moving through in a given amount of time. So when it's rainy or when it's really stormy, you're going to have a greater discharge. The load of a stream, think of your backpack. How much stuff are you carrying? Your backpack is your load here at school. Well, rivers have a load too. And a river's load, there's 3 different types. There's the bed load, which the bed load is these little rocks that kind of, they move a little bit, they kind of tumble around, but they're heavier and they don't get carried up on top of, in the water. They kind of bounce around. They're pebbles and boulders. It's the stuff that you walk on if you step into a river. You're stepping in the riverbed. Then there are the suspended load. The suspended load is all the material that's being carried by the river. So if you have a lot of sand, it's suspended, it's floating in here. It's all the suspended material. If there's a lot of suspended load, it makes the river look muddy. If there's a lot of mud or sand, your river's going to look brown and muddy. Dissolved load would be, you wouldn't be able to see these particles floating around. It's dissolved, it's become, it's all the like minerals, like sodium or calcium, that they've dissolved into the water. You can't see them. It's a homogeneous mixture, so all the, like if you dissolve sugar in water, you can no longer see the sugar particles. They've become a mixture with the water. So dissolved load, think about like the vitamins and or minerals that are not visible, but they're in the water that we're drinking, like, for example, calcium. All right. In the late 1800s, there was a guy named William Morris Davis. You need to know his name. William Morris Davis came up with a couple different ways of describing rivers. Now, we don't exactly agree with the exact, like his ideas that these names for the rivers actually described how old the rivers are, isn't what scientists believe today. However, we do use his naming system to just describe rivers. He was a geomorphologist. He wrote a few books. And he described these couple different names for rivers. The first one is a youthful river. And then we had a youthful river. They're narrow and straight channels. They erode the channel deep, not wide. So you've got a little river going in between two canyons. So it's going to be deep, not wide. You have, they typically are moving fast. They have a steep gradient. Then you have mature rivers. Mature rivers, they erode their channel wide, not deep. So they're a wider river, not deep. And they are slower moving. They have fewer like waterfalls. Slower moving, it has more meanders. Meanders refer to the idea of it's moving back and forth. It kind of curves back and forth like a snake. It has a lot of tributaries. So lots of different sources to the stream, a lot of different little streams coming in and joining this this larger mature river. You have the third one is rejuvenated rivers. And rejuvenated rivers form because of tectonic activity. Rejuvenated, think it's like come back to life. Tectonic activity has happened and it's now a fast-flowing stream again. So it's got meanders, but it has these steep edges because uplift has happened in places, and so now it's no longer flat, but is flowing fast again because of, here we go, because like areas have raised up, and so now it has to meander more around those, or now it's got higher points and lower points, so it's moving faster. The fourth type of river that we describe is the old rivers, and old rivers have low gradients. They're not eroding things very fast, but instead they're depositing more. So they have fewer tributaries. So now, instead of, we still have lots of meanders, but instead of a lot of tributaries joining together, they've kind of merged, and now maybe you have a few less tributaries. So there's fewer tributaries. They're still slow moving, kind of like mature rivers, but sometimes they form what's called an oxbow lake on the side. This is when deposits have happened here and here, and so now this little body of water is no longer connected to my mainstream. So my mainstream's a little straighter than it was before, and I have this little oxbow lake on the side. So, for example, we have here. So like if we started with this river here, say this is a mature river and the water's going down it, and erosion and deposition is happening, and so these areas are getting closer and closer together here, and eventually it's going to result in this more straight, so we go from mature to an old river, this more straight path of the river, and then an oxbow lake on the side. So they're both kind of meandering, they're both slower moving and eroding it wide, not deep. But the one old rivers, you have oxbow lakes. So that's how rivers erode and carry sediment. When sediment is deposited, that's when it's set down. There's a couple different types of deposits. The first deposit is a delta. So we have deposits or deposition. You have a delta, which is this fan-like pattern. This is the Nile Delta. In the Nile Delta, it's this fan-like shape, so you have your river coming up here, and it's fanning out. And a delta is characterized by a fan-shaped pattern that is mostly muddy. It's depositing sediment on a body of water, so like a lake or an ocean. The Nile's depositing sediment into the Mediterranean Sea. So it's onto a body of water is kind of a key point there, but it's going to be this fan-like shape. Now you're going to be contrasting this with the delta to a alluvial fan. An alluvial fan, it's again a fan-like pattern, and it's a deposit by a stream. However, instead of being on a shore, it tends to be in a mountainous area, and it's not in water. It deposits it on land. See, this is your fan-like pattern. You have water coming through here, depositing sediment all through here, and then the streams maybe either dry up or they aren't there all the time. They're just there part of the year. But you get this little fan-like pattern of sediment in mountainous areas with an alluvial fan. So deltas on the water, alluvial fans on land. Your third type of deposition happens because of floods. Floods don't happen all the time the way that deltas or alluvial fans. Alright, so floods are a third type of deposition, and a floodplain is the area that when a flood happens, the water spreads out to. And planting in a floodplain is sometimes a good strategy. Farmers will purposely plant in this area because when a flood happens, all the water that is carried out results in these rich soil. You get fresh deposition of new nutrients from the water. Fresh soil, so it's really nutrient rich and good for planting. So that would be one benefit of farming or of flooding. However, floods are really deadly as well, and so we have loss of life, loss of property and animal habitats that are just really, really dangerous and really deadly. And so a few different ways to prevent flooding are levees, and levees can be man-made or naturally formed, and they're deposits of sediment along the river banks. So sometimes levees are forming naturally just as sediment accumulates on the side of a river, but people put in artificial levees like sandbags to block water from flooding their area. There are also dams, and dams are barriers that they redirect and they hold back floodwaters and reservoirs. So like really bad floods sometimes happen when either levees or dams break. And then a flood can fill a whole town or area. We talked about Hurricane Katrina with that they were just unprepared and that they were below sea level. And when the levees broke, the entire city was full of water then. Okay, you should now be prepared for your chapter 11 test. Make sure you go over your notes and fill out the study guide and have your parents sign and date the bottom of your study guide to say that you watched this video.